Right. So basically, you guys need to take notes for almost for all the slides. If only I specifically tell you you don't need to take notes for a certain slide, then you don't need to take notes for the specific certain slide I tell you. All right, the basic rule, if I spend some time to explain a slide, you need to take notes for that slide. If I tell you specifically, you guys don't need to take notes for this slide, then you don't need to take notes for the specific slide. Right? Okay. Today we start a new chapter. So previously we talked about all the motions, Newton's first law, second law, third law, and energy and momentum. This is all related to motion. Now starting from this chapter, we will kind of change a little bit. We talk about some electrical charge and electricity. Right, this is chapter 16 about electrical charge. So give you guys some preview about what we are going to talk about. So first we'll talk about something basic, fundamental property of electric charge. So we know there's two different kinds of charge, positive and negative charge. So what's the interaction between the charges, right? Second part we'll talk about some the difference between conductors and insulators. What's the difference? And the last part we'll talk about different charging methods like contact, charging by contact, induction, and polarization. So what's the difference? What exactly those term means? Right. So probably you guys knows from middle school science. So there's two different kind of charges. So two kind of electrical charges. We know. So we arbitrarily human being arbitrarily assign them positive charge and negative charge. So we know same kind of charge repel each other. So if we have same kind of charge, they're going to repel each other. This is true for positive charge interaction, negative charge interaction, and different charge attract each other. So we have positive, negative charge. So they are going to attract each other, right? So there are forces involved between the charges, the interaction. So if you take chemistry, or I think probably you learn from middle school science. So in an atom, there's protons, neutrons, and electrons. So protons is positive charge, electrons is negative charge, neutrons, by the name, neutrons mean neutral, so there's uncharged. Right, those origin of charges. So like we know electrons, so we arbitrarily assign the negative sign to electrons. So and proton we arbitrarily assign the positive sign. But we know the proton electrons had opposite kind of charge. So those charge repel each other. Right? So proton and electrons, the origin of all kinds of charges.
Electric charge is a property of matter that generates forces between objects. We refer to charges as being positive or negative. Positive charges are marked with a plus sign. Negative charges are marked with a minus sign. Each of these lightweight table tennis balls has been given an opposite charge. When we release these balls, we see that they move together. Opposite charges attract each other. When charges are the same, however, they repel, regardless of whether the charges are both positive or both negative.
Right. So this is what I briefly explained. So positive charge repel positive charge, negative charge repel negative charge. However, positive and negative, if I have a opposite charge, they're going to attract each other. So there are forces involved between the charges. So later there's a mathematical way to figure out the magnitude of these forces. So later we'll explain this in detail. Right. So in quantum world, the charges, very small number of quantum properties are quantized. So the electrical charge is same as other quantum world particles. So electrical charge quantized. Quantized means there's a fundamental unit of charge, and each charge can only be the multiple of the fundamental charge. That means, so in quantum world, the world is not continuous. You can only have 1, 2, 3, for example. You cannot have 1.5, something like that. So between 1 and 2, there's nothing. You only have 1, 2, 3, for example. Right? So charges, the unit for charges is coulomb. So in short, just use a capital C. So coulomb actually is a quite big unit. So if you pay attention to this, the charges for each electron is only a very small number. It's a magnitude 10 to the negative 19th coulomb. So the charge for electrons and the protons is the same. One charge of proton and one charge of electron, same small number. So coulomb is quite big a unit. Right. So Millikan is a scientist discovered the charge of electron first. So he did a very smart way to figure this out. So what he did is he put some he charged some oil droplets. So in here there's many oil droplets. He charged all those oil droplets and put into a so there's a electric field in here. So I believe positive, and here negative and the bottom, because there's electrons, all the oil droplets are charged by electrons. So in the electric field, there's electrons, the negative charge going to feel experience some forces. So the force is upward. There's a force, electric force, right? However, on the other way, all the droplets have gravity. So there's a weight of all the droplets. So there mg, we talked about the previous chapter. So there's a weight of those droplets. So Millikan can adjust this magnitude of the electric field. So in the way they can have the droplet, the weight of droplet the same as the electric forces. So the electric forces are just Fe equals the weight, equals the weight of droplet. In this way, he can figure out the charges of each droplet, oil droplet. So they can, finally he figure out the charge of each electron, right?
Oil into a chamber and observed them. In Millikan's oil drop experiment, he squirted negatively charged microscopic droplets of oil into a chamber and observed them with a microscope. Voltage applied to metallic plates within the chamber allowed him to create an electric field, which had an effect on the droplets. By adjusting the electric field's strength and direction so that it pushed the droplets against gravity, he could suspend the droplets. By knowing the droplet's mass and the strength of the electric field needed to suspend it, he calculated its charge. Testing several droplets in this way, he found each droplet's charge to be a whole number multiple of 1.602 times 10 to the negative 19 coulombs. This is the charge of an electron.
Right, this is just what I explained on previous slide. So there's a electric force upward, and there's a weight of oil droplets. So he can manage the magnitude of strength of the electric field, make this electric force equal the weight of droplets. So all the droplets in equilibrium. So this way you can figure out the charge of an electron, right? Right, so we know there's two kinds of materials, kind of. One is a conductor and insulator. Conductor, most kind of metals, they are conductor, they can conduct electricity, conduct heat. Insulator, something like rubber and plastic, most of those things, and wood, all kind of stuff, non-metal kind of stuff. Insulator, they won't conduct electricity, conduct heat, something, so they call it insulator. So because within the insulator, charges cannot move freely, but in a conductor like in metal, charges can move freely, so they can conduct electricity. So both insulator and conductor can be charged by contact. So basically, you have something have a charge. For example, a battery probably. You can attach those connect those insulator and conductor to a battery, for example. So the insulator and conductor in contact with a battery. So both either insulator or conductor can be charged in this way. So conductor can also be charged by induction. Later we'll explain what's induction. Oh, here. So induction is basically you bring a conductor closer to a charged object and ground the conductor. So later we'll have a detail explain how this works. Right? Just take notes for this one, and I'll explain in detail on the following slide.
Under certain circumstances, an object can become electrically charged without ever touching another electrically charged object. The process is called charging by induction. Induction occurs when a charged object, such as a rubber rod, is brought close to a neutral object, such as a metal sphere. Because charges can move easily in the metal, the negatively charged rod will repel the electrons in the sphere until the side near the rod is positively charged and the opposite side is negatively charged. If the sphere is then connected to ground, some of the negative charges will leave the sphere entirely. If the sphere is then disconnected from ground, the lost electrons cannot rejoin it. As a result, the sphere has a remaining positive charge even if the negatively charged rod is removed.
Right. This thing, if they have a pod function, it would be better. So basically, if you have something negative charge bring closer to a conductor, so negative charge going to attract all the positive charge, for example, previous. So basically have all the positive charges closer to this negative charge. Negative charge. All the negative charge at the other end of the conductor. If you ground this conductor, all the negative charge will go. However, because it's the attraction between negative charge of this negative charge object, all the positive charge won't be grounded, so it kept in its conductor. If we disconnect its ground, all the positive charge will evenly distributed around its conductor. So this so-called induction. Right, later we'll talk about, well, anyway, so we can move on. Right, so insulators. So we talk about this. Induction is the way to charge a conductor. The insulator can be charged by a polarization. So it's a kind of different. So insulator charged by polarization and conductor charged by induction. So it's kind of similar if you had charged particle closer to an insulator. It's also there's a positive charge going to attract negative charge at the one side of the insulator, and all the positive charge align on the other side, further away from the other positive charged object. So this is called polarization. So this is not. So this kind of just a slide charge separation. So because this insulator. Well, anyway, so you need to know the difference between polarization and induction. Polarization is specifically for charging of insulator, and induction specifically for charging of a conductor. Right, so that's all for section 1. So it just a quick review of what we talked about. So we have a positive charge, same kind of charge going to repel each other, and opposite charge going to attract each other. Right? And so there's a Millikan experiment to figure out the charge of electron. It's a very small number. You don't need to remember the exact number, but probably you can know the magnitude, 10 to negative 19th coulomb. And we also talk about the induction. Induction is for charging of conductor, and the polarization is for charging of insulator, right?